Hello, everyone. Last two trends for this chapter, actually real easy ones. The valence electron trends, and the ionic charge trends. So with valence electrons, you'll see on our chart, we are going to just consider the main group elements, groups 1 and 2, and then 13 through 18. And you'll notice that the valence electrons are actually quite simple. Everything in group 1 has one valence electron, group 2 has two, group 13, this is group 13, 14, 15, etc. This is group 17 and 18. Notice there's a small exception with helium because it only has two valence electrons. But other than that, it follows a nice pattern. Why does it have these patterns? Well, if we take a look at magnesium, it's 1s2, 2s2p6, 3s2. Okay, so it's that one right there. And you notice it has two electrons of the s plus the p electrons in the highest occupied energy level. There's the highest occupied energy level, s2. Okay, looking at fluorine, going all the way to group 17, it's 1s2, 2s2p5. Again, if it's s plus the p of the highest occupied energy level, there we have 7. And they all end in s2p5 here. These all end in s2p5. These end in s2p4. These end in s2p2. Okay, et cetera, et cetera. So you guys can kind of fill in the blanks from there. Now, one step further is let's take these things to now talk about the periodic trends of ionic charges. So if this group all ends in +1, that means it must end in S1 as well. So it's going to have one electron to lose to get a full octet, just like the noble gases. Okay, this will lose 2 electrons to be just like the noble gases. This will lose 3 electrons to be just like the noble gases. Notice we are going to ignore the D block. Okay, carbon, let's group 14, let's ignore that for now. But now these go opposite here. Okay, let me switch colors. Now, watch this. So now we have group 15 has 5 valence electrons. Well, it's actually easier to gain 3, just like to be in some kind of noble gas. Group 16 has 6 valence electrons, so it's easy just to gain 2. So that'll be -2. So these will be +3, -3, excuse me, -2, -1, and of course 0 because they have a full octet. So we're always looking for that full octet. Okay? And that's all I got for that. Let me know if you have any questions.